All right, you're back. You made it through part one. And while in our previous video, we discussed AI hallucinations, specifically on defining them, what they are, and that being fabricated, very confident and almost plausible, but fabricated outputs. In this video, we're going to discuss more of the detections, how we can identify them in our usage, whether that's personally or at an enterprise scale. And one thing I didn't point out maybe in great detail in the last video is the why of it all. Why does this matter? Why are we talking about AI hallucinations? Is it just because it interests me? Perhaps. But I think it's important to at least state, and it might be fairly apparent, but to state that this idea of AI hallucinations is, and being able to define what it is, to detect what it is, to defend against those occurring within your usage. It's important for maintaining trust, for ensuring reliability, for avoiding security or significant risks. And that applies to any size of implementation, right? From individual user, small, medium, large business, or enterprise scale level. And so that's the why of this all. And specifically in this video, as we talk about detection, the approach to detection should scale with the size and complexity of the business. So maybe what you institute for yourself as a user will vary greatly as far as your checks and balances. Might vary greatly from someone with 1,000 users of AI within their enterprise. So these are the components of detection. And we'll do another video that talks maybe more specifically about how to set up detection or what you might use depending on, your scope. Now, it might be easy to think like, I'll know when it's wrong, right? My little internal radar will go off and say, this seems suspect, this seems incorrect. And it's good to trust those instincts. It really is. I want to, in the whole of this discussion, I want to really engage your mind and engage your intellect when it comes to using AI systems, and specifically to spot and look for hallucinations. To know that this can and does occur is important in the detection process. But a key challenge with hallucinations is that they operate kind of in what we might call like a stealth mode. They don't typically generate system errors or a 404 error, come across the screen. And so therefore they're kind of invisible to traditional passive monitoring tools that might simply log, successful or unsuccessful API calls. To your system, it looks like a perfect API call. And so instead of relying on just spotting it later, like driving a car only using your rearview mirror, right? So you're just like, let me see what I hit, instead of paying attention to where you're going, instead of actively hands-on detecting what's occurring around you. So that's what we want to do. We don't want to be merely reactive. We want to talk about some of the detection principles that we can be proactive so that we can have real-time checks and balances to those AI systems that we're using. It's called active alerting. They're real-time systems specifically designed to inspect the content of AI interactions and to flag questionable events or outputs. So, instead of a rear view mirror, we're going to focus on headlights and, alarm bells going off, how to set those types of things up. The first principle we'll talk about is source checking and cross-referencing. It's one of the most fundamental detection strategies that we can implement. When an AI model provides a citation or refers to a source to support a claim, verification process must be employed. This is typically a two-step process. First, URL validation, which confirms the cited source actually exists and is accessible. This can be automated to check for things like HTTP or HTTPS status codes, right? Secondly, content cross-referencing. This ensures the information within that source genuinely substantiates the AI's claim. It can be a manual or semi-automated process that serves as a critical first line of defense against easily identifiable fabrications, especially in a academic, legal, or research context. It may have somewhat of a, subject matter expert overview within that as that cross-referencing happens. But a lot of this can be determined from merely citing sources. So fact check external sources. Moving beyond that, we can evaluate the internal logical coherence of an AI's output. What does that mean? Automated reasoning techniques can be applied to parse generated content and check for self contradictions. For example, if a model generates a report stating that a project was completed on Tuesday, and later within that report states that the project is still 3 to 4 months out, that is something that should be flagged as logical inconsistency. It's a failure of logical reasoning, and it's a strong indicator of a potential hallucination as the model is generating text without a true understanding of its meaning. Another approach, which is both cost effective and a powerful technique for automated hallucination detection, is something called LLM as a judge. This method leverages a second independent, often smaller and kind of dedicated large language model to evaluate the output of your primary LLM. The process is pretty straightforward. The output in question is passed to the quote unquote judge model along with the original source context that it was supposed to use, or the original prompt and any attachments you might have. You copy and paste it into that almost specialized detective AI model and ask, based on the known facts, is this statement accurate? You'd be amazed at how often one AI will call out another's hallucination. It's kind of the robot equivalent of asking for a second opinion. And it's surprisingly accurate. I like to think of it as like peer review, right? You're using one LLM that maybe you've set up parameters specifically to check for hallucinations and specifically to check for accuracy. And you're using that to feed the outputs from your main LLM source to double check and to cross another version of cross referencing. You can set up a hallucination score within that smaller judge LLM that can output, across the range that's predetermined how accurate and correct that was based on its context, based on what it was given for reference sake. And research has shown that this method is highly effective at identifying, specifically context conflicting fabrication with pretty great precision. And that's kind of the low hanging fruit. Again, you want to scale your detection techniques based on the size and scope of your operation. So, for a large operation, those things probably would take a lot of time, a lot of manpower. For enterprise scale applications, manual checks are just merely insufficient. Organizations have to rely on scalable, automated systems, kind of interwoven within their machine learning operations or workflows. So, we want to pop the hood, so to speak, and explore maybe some of the core technologies that go into those sophisticated automated detection systems that you might see more on a enterprise level. Firstly, I want to look at factual consistency and grounding checks. How do these work? To ensure an AI generated output is grounded in a body of verified information, systems perform factual consistency checks. A common technical approach is called semantic triplet extraction. For instance, a statement like this: the song I Ran So Far Away was originally performed by the English new wave band A Flock of Seagulls in 1983. And it'll break it down into that triplet of information. I ran so far away, originally performed by A Flock of Seagulls, and it kind of separates it into its core components. So you kind of have almost that like subject, verb, object aspect of its core components. These triplets are then converted into numerical vector embeddings, basically representing their semantic meaning. The system uses mathematical calculations to compare the vector of the AI statement to the vectors within an authoritative knowledge base. And any sort of low similarity score would indicate a significant deviation from the established facts. This is especially critical for RAG systems, or retrieval augmented generation, which are explicitly designed to be grounded in a provided context. We can also gain insights by analyzing the model's internal metrics during generation. It's often called uncertainty quantification. Basically, token level confidence scoring, which examines the log probability the model assigns to each word or token it selects. A low probability signifies high model uncertainty about its choice. So almost like the AI model is like, yeah, I'm just going to throw this out there, right? We want to know how confident it is with its output. And that's something that can be used and is used in detection systems like this. It's established by a dynamic confidence threshold, and automated systems can flag any output where the model's certainty falls below whatever is set as an acceptable range, indicating it's more likely guessing rather than stating or outputting a known fact. In real simple terms, you could think of it as asking the AI model to produce 5 to 10 outputs for the same prompt, for the same request. And based on its variation, you can determine how certain it is or the level of uncertainty that that model has in that output, which again is a sign of, maybe some deterioration or even some hallucinations within the model itself. One methodology is called the Burt Stochastic Checker methodology, which prompts the model to generate multiple responses to the same query using a higher temperature setting. We talked a little bit about that on the definitions video, where that higher and lower temperature kind of relate to the model's creativity or introducing randomness with the higher temperature versus the colder temp or lower temp rather being more factual and conservative almost. So in that, using that higher temperature model, it then compares those responses, and factual statements should remain pretty consistent across all outputs, whereas hallucinated details will have that great amount of variance. And that's what I'm kind of talking about there. It's resulting in low similarity scores and a high probability of fabrication. There is also token similarity detection, which provides a more direct comparison to source material. Metrics such as blue or rouge scores analyze the lexical overlap between the AI's generated answer and the original source text. Blue scores a sentence generated by an AI model compared to a human written sentence, and it especially this for tasks like machine translation. At its core, the blue scores primarily focus on precision. Comparatively, the rouge score is another natural language processing metric often used for evaluating summaries or machine generated text, particularly when you want to make sure the AI captured all the important information from the source. The blue score focuses on precision, the rouge score focuses primarily on recall. The blue and rouge scores work by comparing n-grams or consecutive sequence of words. So 1 gram would be a single word, 2 grams, two word. You get the idea. Between the AI generated text and one that would be more human written or a reference text. A low score within these metrics indicate the AI's response uses very different words than the source, which can also, again, signal a hallucination or where the model has kind of drifted off topic. They monitor and alert for much more than just factual inaccuracies. These systems are essential for security, things like monitoring for prompt injection attacks, for prompt injection signatures, malicious use. They help enforce guardrails and compliance when it comes to things like prohibited explicit output or even leaking of PII, personally identifiable information. Additionally, they track quality degradation or AI model drift, alerting development teams and internal teams when a model's performance starts to decline over time. This integrated approach ensures comprehensive AI governance. And I touched on some of these, but just in quick review, wanted to go through basically the broad and maybe more subcategories of detection processes. So you have ground truth validation, methods that verify the AI's output against an external authoritative source of truth, factual consistency checks, source checking, cross-referencing, that semantic token similarity. You have internal coherence and consistency analysis, analyzing the generated text itself for flaws, not necessarily needing anything external as a cross-reference. You have model internal statistical analysis that just examine the model's own internal data during generation. You have external review and oversight. That's an independent agent, a human, or the LLM as a judge output. And then you have system level monitoring and alerting, kind of a strategic high level approach, again, at scale, integrating many of these detection methods all into one and one operational framework. Okay, so you're thinking, cool, 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 cool. We've talked about AI hallucinations. We defined what they are. We have talked about detection, right? How that process actually happened. What is being done? What does this mean for you? What does this mean for me? How do we build strategies or where to go from here? In our next video, we'll talk more about the defense side of things, how to set up some of these detection tools, how to defend against hallucinations, and how that kind of correlates a little bit with AI security. I want to talk about how that can be implemented depending on scale. So for you as a user, small business, medium-sized business, large business, again, you want to think of with AI security and with AI hallucinations specifically here, we want to scale with the scale of the organization. But I want to give you three quick things on setting up what might be called an AI firewall, right? This isn't just about finding mistakes. It's about how do we put guardrails in place to prevent them from reoccurring and damaging your business, your reputation, trust between you and your clients, trust between you and usage of the AI models that you use. It's all about implementing that active alerting. So think of it real quickly, three tiers, right? Human in the loop for any critical task you have, a client email, financial report, legal summary, make sure that there's a human in the loop. One of the huge things about a legal instance where I think it was a lawyer or attorney had utilized the report that was fabricated information within a ChatGPT output. And that was kind of highlighted as like AI hallucination issue. When I see that as a human issue, that was something where you have to fact check things, especially in critical tasks. I think regardless of the size of your organization, there's going to be some things that you have to mandate a human being involved in or a subject matter expert being involved in for review. Just can't leave it completely up to systems, especially systems that are probabilistic in nature, such as AI or LLMs. Simple automation, things like LLM as a judge, like we mentioned before. You can create a simple script that automatically checks for an output with a second AI or asks for multiple variations to check for consistency before it gets to your team, before it goes out from your team into the world or out into, presentation or reporting, that type of thing. It can be done at random or on a consistent schedule or even daily, depending on cost of API calls or the size of your organization. So that's kind of your tier two, as it were. Tier one being human in the loop, tier two being simple automation, tier three being the pro setup. That's your AI observability platforms. And those are where you're going to pay for that system or that setup. But you get what you pay for. They monitor everything we've discussed: hallucinations, latency spikes, anomalous token consumption that could be costing you a fortune based on your scale, and even attempts to leak PII or some of the malicious parts of that. But the main takeaway I want for you is this: you are not helpless. This is not too complex of a thing for even instituting simple checks and balances. In part three, we'll look at that mitigation and prevention, the how-to or actual ways you can set up detection and defenses for yourself as an individual or for a large enterprise at scale. Everything from open source free tools to fully integrated real-time monitoring of every single output to help ensure that our AI applications are and remain reliable and trustworthy. But managing AI systems, think of it like an ongoing investigation, not a one-time fix. Proactive detection is not an obstacle to AI innovation, but rather a cornerstone for responsible and sustainable development and deployment of AI systems.